Hi, everybody. Welcome to another video in the series that I'm doing on controls engineering in the context of Disney and attraction engineering in general. We spoke about hardware in kind of an overview fashion last time, and this time we're going to dig a little bit deeper into kind of the fundamentals of controls hardware a little bit for you. Controls hardware, first and foremost, is there's a lot of manufacturers in this space, right? That are making the actual hardware that we work with. Some of them are very niche. They make robotic arms and that's it. They just make robotic arms and they're fantastic at it. It's what they do, it's their brand and they're awesome. Other companies are very broad based. They kind of like Apple, they like to create ecosystems where you have only their product, their hardware, their software, their everything. And like I said with Apple, you have their tablet, their desktop, their phone, the AirPods, the special charger. All you get hooked on Apple technology because it all plays nice together. Same kind of rules apply. And as far as our specific conversation in the context of attraction engineering, there's three companies that we care about, and that's the wrong one. That's these three guys. These three guys are Siemens up on the top, which, if you've ever been to Epcot and ridden on Spaceship Earth, you may be familiar with, sponsored by Siemens. And they are the big dog in Europe. They dominate the market over there in terms of industrial facilities and industrial applications. They make PLCs, IO, they make software platforms that we'll discuss in the software video series. But they dominate over there. And I actually ran into a situation last week where there's a UK company that is expanding into the US. They are building facilities over here and they are looking for Siemens controls engineers to handle the construction and implementation of these facilities. And they're having a lot of trouble finding those people. Over in Europe, where Siemens is dominant, they have a lot of people who specialize in Siemens. And the company, as they're UK based, all of their facilities over there are Siemens. So, um, as an ecosystem, they'd like to keep all of their facilities on Siemens technology. So they have one unified platform. They have one company that they call for troubleshooting, one company that they buy replacement parts from. Everything's nice and in one place. And they're having trouble finding people over here to do that work for them because in the US, Allen Bradley is the equivalent company. The big dog in the US that has the dominant market share is Allen Bradley. The vast majority of industries here, food and beverage, pharmaceutical, oil and gas, attractions, in other theme parks and things like that, they utilize Allen Bradley because it's the long-standing dominant player in the US. They have hardware platforms, software platforms, IO, PLCs, you name it. This switch here is an Allen Bradley unmanaged switch. So they make pretty much everything. You can run in an entire facility purely on Allen Bradley technology if you want to. And that's what the US specializes in because that's what everybody buys here. All of our engineers specialize in Allen Bradley because that's what they use. Um, so there's a bit of a dichotomy there where European companies try to come over here and they want to stick to what they know, but we don't know it because we don't use it. Siemens has a share here, but nowhere near as big. The same problem goes in reverse. Allen Bradley has some of the market over there, but nowhere near as much. So people don't specialize it in as much over there, and it gets kind of there's a bit of a wall there in terms of knowledge and specialization. So the company in the middle there is Beckhoff. They are a German-based manufacturer. They make PLCs and IO. They have their own software platform, as all of these companies do, and they're relevant to this conversation because that's what this guy and these guys are. This is Beckhoff hardware that I'm holding in my hand here. Um, this is hardware that I've used extensively to connect some dots on your own, and they're making they're really good stuff. I like it. I'm not sponsored by them. I wish I was. That'd be very helpful right about now. But they make very good hardware. It's not as trusted in the U.S. as Allen Bradley is yet. It's getting there. They're kind of expanding and gaining market share and all that kind of fun stuff. But working on it. It's good stuff. I like it. It's a lot of fun, but it's relevant to the conversation because it's what I'm physically showing you in these videos here. So, hardware fundamentals. Hardware typically comes in a couple of two flavor varieties that stack up on each other. So, we typically deal in low voltage or high voltage systems, and never the twain shall meet. Um, for safety reasons, which we'll get into in just a second. So, low voltage is the kind of hardware that I'm allowed to touch as somebody who's not a certified, licensed electrician. Low voltage is where I cap out. Um, Most of the control systems that we do or did as is low voltage, and most of this is all low voltage. Allen Bradley makes some higher voltage IO slices that directly do higher power control. But the vast majority of what we do with control systems is all low voltage, and then there's a bridge point in the system that trips the high voltage stuff from the low voltage side, so that way we don't have to touch the high voltage stuff. That's electricians only. Um, that low voltage, high voltage also typically splits DC versus AC. It's standard electricity stuff, alternating current, direct current, and your low voltage control systems are pretty much exclusively DC, 12 volt or 24 volt, 24 volt being the norm. And if you're dealing with high voltage, it's typically AC. So you have 120, 240, 480 volt AC control systems. And that's the electricity that we're pumping directly into heavy duty industrial equipment. If you're dealing with 480, it's a motor that's like lifting a heavy curtain rig in a high speed, or it's running a heavy duty metal stamper in a steel manufacturing plant, like high voltage stuff. That's off where the electricians play. I don't touch that because I'm not going to die. So typically, the way that we, as I said, there's that big divide in the middle there. Anything that's low voltage, I can do myself. Like I can stick my head into a control cabinet and wire all this up and troubleshoot this if somebody makes a mistake, or I need to, like, if one of these slices goes bad, I need to swap it out. I can put the wires back in the new slice myself because it's low voltage. And then what we typically do with the cabinets, which I showed you a picture, they kind of look like this or like that kind of a thing. This would all typically be low voltage. You can see down here, this guy that says Sola on it is one of these. It's a DC power supply. It takes, would probably help if I had it right side up. It takes 120 AC like you would have in the wall of your house into the bottom, and DC comes out the top, so we can wire it to a whole bunch of things all in one. Like we can wire it up to this whole bank of IO terminal blocks here. And that's an efficiency thing. If you look at a lot of appliances and electronics in your house, they have those big power bricks, and each individual appliance has its own little brick, and that's converting the AC power coming out of your house to DC power that the device can actually use. And this guy is basically a consolidated version of that power brick. Instead of having each individual device need its own brick, we just have wall power, DC power, and we wire it out to, dozens of things in the same cabinet, right? You can see there's only one of those supplies down here, and it's powering all the DC stuff that's in this cabinet successfully. So one of these does the job of what, if you were doing it with traditional power bricks, would be dozens of bricks running to each individual thing, and that just gets real messy real fast. So we use big chunky guys like this to consolidate all of that down. It's all about getting things manageable as quickly and tightly as we can. So that's that. AC, DC, low voltage. Oh, the other sort of big dichotomy is analog and digital. That mainly comes into play with these guys because you have, as I said, you'll have AC and DC versions of IO sometimes if you want. Allen Bradley in particular has 120-volt AC IO cards that could hook up directly to their processor. So you pass, it's basically a card that functions like a relay does. You have 120 come up and into the card, and then a wire, like a dead wire, comes out the other side, and it closes the connection between the two to let the 120 go through. So the card itself doesn't do 120; it just passes 120 through it when you turn on the individual spots. But as I said, most of what we do is DC and analog digital IO. The difference between the two is pretty straightforward. Analog is anything with a range of values. So your temperature probes, pressure. If you're looking at something that's going to give you 0 to 100 psi, that's an analog value because there's a range of values that it can hold. And digital IO is on and off. It's a 1 or a 0. That's it. You have power coming out of it or you don't. You have power going into it or you don't. Digital versus analog. So those are sort of your absolute fundamentals of controls hardware. Then what you run into beyond that is, I mentioned a little bit with the switches, network topography, kind of laying out Ethernet cable and fiber optics and all that kind of stuff to get your field IO and field devices in contact with your processor or your processor and your local IO and keep everything kind of interfaced and networked appropriately. So that's sort of your absolute most fundamentals of controls hardware. Some of it seems pretty straightforward, but I want to make sure that we're taking this in nice, clean steps forward. Which this is where one of the questions that I got asked on Twitter comes into play. So over on Twitter I asked for questions pertaining to hardware, and Holly asked, within your ability to be as specific as possible, what hardware has been the most challenging to work with? And hardware comes in sort of three categories. There's off the shelf hardware for an off the shelf application. That's where you buy something that specifically says on the side of the box, designed to do X. Fantastic. You take it, you install it where you want it to go, and it will do X out of the box just like it says on the side of the tin. If you run into problems with that for whatever reason, if the part's defective, it's not doing what it's supposed to do, the instructions are vague, you can call the company and speak to tech support. They have people that do this for a living. You call them, you say, hey, your thing's not doing the thing it's supposed to do. What the heck? And they will work with you to make it do that thing. That's what they're there for. And they're great about it for the most part. Sometimes you stump them, and that's always fun. But that's relatively easy to work with because you have that second layer of support. You're not on your own. You have them to fall back to and say, hey, I bought this thing. It's supposed to do it. And for whatever reason, maybe I got a wire backwards or the diagram's upside down, something stupid. Help me out real quick. And they get to resolve. So that's pretty easy. At the complete opposite end of the spectrum is custom, which is custom hardware, custom software for a custom application. The most straightforward example of this that I can give you is the animatronics that we build. The animatronics are custom specified, custom machined. The software that runs them is completely custom and proprietary to Disney. It's 100% internal us stuff. And every individual part of it, all of the motors and the cabling and the brackets and the individual pieces of metal that construct the body are all custom ordered from manufacturers to exacting specifications, right? There are very, very tight tolerances on some of this stuff. You have a hand that you want to be able to move the fingers, right? And there's not a lot of space in here for cables to just kind of be wherever. You've got motors in here, you've got sensors to give you feedback. everything's very tightly toleranced, right? Because you don't want things to look messy and bulky. So um, we specify that in exacting detail to companies. We say we want our motors to be these specific sizes, and it has to do these specific things within these tolerances. If it doesn't, we rip them a new one and send it back and make them send us a better version, because this is what we're paying top dollar for them to do, is give us exactly what we want. And that's complicated because we don't have a support team. We are the support team, but it's easy because everything is custom tailored to do that one specific thing the way it's supposed to do it, right? From top to bottom, everything is customly written or specified or constructed to do that job exactly as it's intended to do. So that's also pretty straightforward. The thing where it gets really interesting is the space in between the two. That is where you buy an off the shelf part to do a custom application. It's a bit like when your doctor prescribes you medication off label. It's not technically meant to do this, but take it and give it a shot. And that is absolutely the hardest kind of situation to be in, because you're trying to fit a square peg into a round hole. And sometimes you can do it. Sometimes you did it just right and the fit's there and you can squeeze it through. And other times you're basically putting a square peg through a brick wall. It's just not going to happen. And I've actually been in that situation. I was actually in that situation with two companies at the same time. We had two pieces of hardware that we were trying to interface together, and I could not get the two of them to play nice with each other, no matter how hard I tried. I was writing a custom piece of software to get the two tied together to do what we needed them to do, and it's not something that they're explicitly meant to do. They're not designed to play nice together. It was a bit of a reach, and I called up company A and said, "Hey, I've got this part of yours, and I've got this other part from this other company, and I'm trying to make them talk to each other. Can you help me?" And basically, they looked at me and said, uh, "We've never tried that before. We have no idea if that's actually going to work. If they use this particular communication protocol, it should work, but we've got no idea. We can't help you. Sorry." Click. End of phone call. That was all the help I could get out of them. Was, in theory, maybe it should probably kind of work. And I called up company B and said, "Hey, I've got this part of yours and I've got this part from company A, and I'm trying to make them talk to each other. Can you help me?" And basically they were like, uh we got nothing. We've never tried that before. We have no idea if that'll work. Honestly, we doubt it'll work. If you get it to work, we would love to hear how you make that happen, because honestly, we're just kind of like, ugh. And click. That was all the help I could get out of them. So, as it turned out, the two pieces of hardware, that one communication protocol, that the company was like, "Oh, well, if they use this, then it should work, right?" Um, Both of them in their documentation say, "Hey, we use this communication protocol." So I was like, "Oh, great. I'll just use that and I'll get them to talk to each other with a little bit of custom software in between. No problem. Communication protocol." The trick with that is that in the very fine print of a separate piece of documentation that you had to go dig out of the bowels of a website somewhere, this company only implemented that communication protocol partially. They said, "Hey, it's a communication protocol. Realistically, we're only ever going to need these five or six things that are a part of it. So we just didn't bother to implement the rest of it yet. We'll get around to it eventually. But for now, we just did these really super important bits because nobody's ever going to use these other bits for what we do with our product." And the critical piece of information that I needed to get out of this guy and out of this guy and pass in between the two through my software was one of the bits that they didn't bother to do. So these guys are like, "Oh, they use that protocol. Psh, should totally work. That's what the protocol is designed to do, is communicate between two things. And I was like, oh, great. Um, the problem was there was a really important bit that this needs that this didn't bother to do. And they're just like, we don't. So it's just screaming into the void. And my software is like, I got it. I got it. I'm passing it on. What the? And so that is the nightmare scenario, is you take something off the shelf to do something that it's not designed to do. And the company that you would normally call to troubleshoot an on label application and just looks at you and says, if you figure it out, tell us so we can tell the next guy. And that's all they got for you. They don't, that's not a thing that we endorse. So you're on your own, deal with it. And it's like, ah. So yeah, so that's about as specific as I can get. I don't want to get too much without calling out individual sort of companies and parts and attractions and things like that. So, um, yeah, you've got your off the shelf. You've got your custom, and then in between is off the shelf for a custom purpose, and that's where everything gets messy in hardware side of things. You can massage it for days with your software application, but at the end of the day, sometimes it's a square peg through a brick wall, and it just ain't gonna happen. So, hopefully, this took things a little next step deeper for you on the controls hardware side of things. I think I've got probably one more of these worth of good information before we start getting into really just kind of like specific applications, which I don't want to go talking out of telling tales out of school. So we'll see you next time. We'll start transitioning into the software side of things and start talking about the design process of all of this, and just kind of keep these videos rolling for you. And hope you learned something. Hope you enjoyed it. We will see you back here next time.